So initially, as you can see, the power on switch has not been turned on yet. So there's no current flowing through this conductor, and therefore this ferrite core cannot become a magnet. It has not been electromagnetized yet. So, but if the switch has been turned on, current will flow through this conductor, and therefore this ferrite core will form an electromagnet. Now we have 60 turns of coil turning around this core of ferrite core. So now we will see how many pins we can attract. So left 4 remains.
Okay, so this is the 45 turns of the coil. We are left with around 6 paper clips.
Next, we begin with the 30 turns. I will demonstrate how many pins will be attracted with 30 turns. And we can see that there are 5 pins that are attracted by this electromagnet.
This is the result for 15 turns. So as we can see here, there's no paper clips attracted to the ferrite core. So we can conclude that 15 turns is not enough to magnetize the ferrite core.
Now I will explain in detail about our experimental results, how the number of turns of coils on the core can affect the magnetic field strength. Right, firstly, let's imagine the straight piece of wire that our magnet is made up of before it's wrapped up in coils. Now, if we run a current through it, will it turn into a magnet? Alright, the answer is yes. This is because any electric charge in motion creates a magnetic field. The magnetic field lines run in a concentric circles around the wire. The magnetic field strength of the electromagnet depends on the type of core material being used, since the purpose of the core is to concentrate the magnetic flux in a well-defined and predictable path. In this experiment, we use a ferrite core, even though it's not the best, because of its high magnetizing and demagnetizing property.
Now, if you coil the wire around this core, the direction of the magnetic field line will reshape, and the direction of the circular field line can be identified using our right hand grip rule. You can hold the coil in your right hand, and the current flow in the direction of your finger are pointing. This is the direction of the current. If you're holding like this, the current is going up. And the north pole is the end where your thumb is. You can add more coils on top of the first row, and this will just add more field strength to the core. And in technical terms, every coil of wire increases the magnetic flux density, or we call the magnetic field strength of the magnet. Next, the amount of magnetic field generated by the wire can be calculated if you know the length of the wire and the current, and of course the number of turns of the coil. Then, to summarize our experiment on the magnetic field strength on the electromagnet, the factors depends on the following. First is the number of turns of the wire within the coil. Second, the amount of current flowing in the coil. And the third is the type of the core material. However, we fix the type of core material at the ferrite core and the amount of current flowing, which is 11.4 milliamp. However, we change the number of turns of coil within the core around from 60 to 15 turns. So that is all from our experiment.